So one of the homework problems that I'm going to give you is going to be page 76, number 55. So I wanted to go over number 56 right now. So here's page 76, number 56 and 55, they have the same directions. It says, sketch a graph of the function y equals f of x that satisfies the stated conditions. So we need a function that satisfies each of these conditions. So for number 56, these are the conditions we have. So I want to point out that what we're doing has to be a function, and it has to be just one function, all right? So now let's think about how we could do that with these criteria. So I'm going to start with a blank graph. Let me just give you this bit of foreshadowing here. This question is important because we're almost finished with this unit. We just did 2.2, which is limits involving infinity. After that, the next section is continuity, which we've already talked about. The next section after that is rates of change, which is what our whole limits 1, 2, and 3 was about. So we've actually finished this whole chapter. And so we're going to do an assessment on the chapter. The assessment is going to be like a project or maybe like a hard take-home quit test. That's what this is going to be like. It's like a take-home test. And one of the questions on it is going to be just like this. You have to come up with a function that has certain criteria. So I'm going to show you how you can do that. So let's look at each thing that we have. So it says the limit as x approaches 2 of f of x is -1. So as x approaches 2, we want to get to -1. So we don't know what the function is doing in here, but it has to somehow or other come up to that 2 and go away from it. So I don't want to draw much of the function just because all this tells me is about what's happening right around x equals 2. So I'm not going to draw a big thing because I don't know what else might be happening. So I'll just draw like that. I could, by the way, fill this point already, because the limit would still be -1 as x approaches 2 if the point were filled. I chose to leave it open for now. Let's look at what else we got. Limit as x approaches 4 from the right is -infinity. So let's look at x equals 4. And so one thing I might notice by looking ahead is that as x approaches 4 from the right, the limit is -infinity. As x approaches 4 from the left, the limit is +infinity. So what I'm looking at here is an asymptote, a vertical asymptote, and in fact it's an odd vertical asymptote where the limit doesn't exist. So now let's try to make these things happen. As we approach 4 from the right, we have to go to -infinity. So approaching from the right, we have to go to -infinity. Now I don't know what's going on over here, so I'm just going to draw this little part of the function. And as x approaches 4 from the left, I need to reach +infinity, so I'm just going to go like this. Now notice if this went over here, then here and here, the graph would not be representing a function. So I would not have I would have the same x with different y's. So I have to be careful that none of the pieces I'm doing overlap, because if they overlap, if I have pieces going like that, then I don't have a function anymore, and it says it has to be a function. Okay, now, so I got those things. It says the limit as x approaches infinity is infinity. So that just tells me end behavior, that as the x goes out toward infinity, the graph is going up. Okay, I don't know what anything else is doing, it's just going up over there. Now, as x approaches -infinity, f of x is approaching 2. So that is a horizontal asymptote, but only to the left, because it says x is approaching -2. So I have a horizontal asymptote this way, but not this way. All right? So, and I know that the graph has to somehow approach that. All right, so now I've sketched in the little parts of how the function can go. I just have to connect it up in such a way that it's still a function. Well, if I want to connect this to here, I pretty much have to go fairly straight up, and maybe we'll sort of straighten that up so it's just one thing. That's a big blur, but that's what it does right there. Okay, I could have it do other things in there, but I had to do that. Now I got to connect to this piece over here. It didn't say anything about what the y-intercepts or x-intercepts are. They could be anything. So I could go down and I could come back up. I'll just try to keep it simple. I mean, as far as I know, this could go down and come back up and cross the horizontal asymptote and then come back down. Remember, a graph can cross a horizontal asymptote, just not a vertical asymptote. And then what's going on over here? Well, I could go like up and down and like that, but let's just keep it simple. Let's just say it goes like that and they connect together. All right, so now I see that the limit as x approaches 4 from the left is infinity. The limit as x approaches 4 from the right is -infinity. The limit as x approaches infinity is infinity. And the limit as x approaches -infinity is 2. And also the limit as x approaches 2 is -1. Now if I wanted, I could put a function value here. If they told me, for example, that f of 2 was -2, I could put that function value there. But I don't have to. They didn't tell me what the function value is. I could put a point there, or I could leave the hole there, or I could fill the hole. because in any of those cases, the limit as x approaches 2 of f of x equals -1. So there are many different ways to draw the function. That's one way that I chose to do it. So you're going to be needing to do that in an evaluation. Okay, so now, so you get to try number 55 as homework. In fact, here's your homework, is page 76, number 1 through 7 odd, 13 through 19 odd, and 55. And then something I'm going to do sometimes is pull from another book. I like John Rogowski's book, page 105. And what I've done is I've posted this on the Google Classroom, and I've posted it on the website. It looks like this. And I just wanted it because it had more limits as x approaches infinity and negative infinity. Your book doesn't really have a lot of that. So I pulled these for that, and it's on the website. That's your homework. Now, but I actually have one more thing to discuss with you, so I'm going to save that for the next video.